Next, I'm going to introduce the quotient rule. So if a is any real number and r and s are integers, then a over r divided by a over s equals a to the r minus s. Now, why does this work? Let's say I had 3 to the 4th over 3 squared. Well, that would be 3 times 3 times 3 times 3 over 3 times 3. These two 3's canceled, and I'm left with 3 squared, which is conveniently 4 minus 2. So let's work through a couple examples. If I have a to the m over a to the n, that becomes a to the m minus n, and I can't simplify this any further. If I have 4 to the 6 over 4 squared, that becomes 4 to the 6 minus 2, which is 4 to the 4th. If I have k to the 7th over k to the 13th, that becomes k to the 7 minus 13, which is k to the negative 5. And as we learned in our, negative 6. And as we learned in our previous rule, if I have a negative exponent, it's a fraction. So I'm going to put that under 1. So I have 1 over k to the 6th. Now, I'd mentioned in the last slide that if we have a negative exponent, it moves to the top. Let me show you how this works if we just follow the quotient rule. We'll get the same answer. If I have 3 to the 8 minus the negative 5, that's 3 to the 8 plus 5, which becomes 3 to the 13th. If I had moved that 3 fifths to the negative 5th, if I had moved that to the numerator, we would have gotten 3/8 times 3 to the 5th, 3 to the 5th, and we would have added those and gotten the same answer. So as long as you follow the correct rules, you're going to get to the correct answer, but this one took a little less work, in my personal opinion. Next, we have the power rule. If a is any real number, and r and s are integers, then a to the r to the s power is a to the r to the s. Well, why does this work? Let's say I had 2 cubed squared. That's like saying I have 2 cubed times itself twice. Well, that would give me 2 to the 3 plus 3, which is 6. Well, 6 is conveniently 2 times 3, so therefore our power rule works. If I have a to the m to the n, I'm going to multiply those. So I'd get a to the m n, and I can't simplify that any further. If I have a b to the m, I need to distribute that m. That's going to be a to the m, b to the m. I'll also distribute over fractions, right? Because if I had 1/2 squared, that's 1/2 times 1/2, which would be 1 over 2 squared, right? It has to be distributed. So I have a to the m over b to the m. If I have x to the 4th to the 7th, that's x to the 4 times 7, which is x to the 28th. If I have 3x to the 5th squared, I have to distribute that square. So I have 3 squared, x to the 5 times 2, which gives me 3 squared x to the 10th. And if I wanted to, I could simplify that 3 squared down to 9. It's not required. If you know it off the top of your head, feel free to, but note that in some of the My Math Lab homework, it does ask you to keep things in exponential form. If I have a over b to the negative n, that becomes a to the negative n over b to the negative n. Now I'm going to slow down here. Remember our negative exponent rules? If I have an exponent in my numerator, it goes down to the denominator as a fraction under 1. If I have an exponent in my denominator, it goes to my numerator. So our final answer is b to the n over a to the n. So how do I know when an exponential expression is fully simplified? So each base should occur only once. There should be no parentheses, no powers are raised to other powers, and absolutely no negative exponents, things that make math professors say, ew, negative exponents. No negative exponents or 0 exponents occur. So why don't we work through an example? Let's work through 2 examples. So there are multiple ways to approach this as long as you use the correct rules. So let's start over here. If I have x to the negative fourth y squared over x squared y to the negative fifth, I'm going to go ahead and use the quotient rule first. I have x to the negative fourth minus 2 times y squared minus a negative 5. That gives me x to the negative 6, y to the positive 2 plus 5, which is y to the 7th. So I have x to the negative 6, y to the 7th. Because I have a negative exponent, that's going to go in the denominator. So I have y to the 7th over x to the 6th is my final answer. And this is fully simplified. I have two bases, x and y, that each occur only once. No negative exponents, no exponents of 0 or 1. Let's take a look at this next example. I have 3 to the negative 1 times m to the 4th times m to the m squared to the negative 1st over 3 squared m to the negative 1st. Let's start by simplifying that numerator. I've got 3 to the negative 1, m to the 4th, and I want to get rid of parentheses, right? If we use gems, we get rid of grouping symbols first. If you're using PEMDAS, it's parentheses. Both are ways to approach order of operations, as we talked about earlier in this course. M to the negative 2 over 3 squared m to the negative 2. I'm going to go ahead and combine my m's in my numerator. If I have 3 to the 4th plus times m to the negative 2, that's m to the 4th plus negative 2. That's going to give me 3 to the negative 1, m squared over 3 squared m to the negative 2. Now I'm going to use the quotient rule. So I have 3 to the negative 1 minus 2, m to the 2 minus a negative 2. So that would give me 3 to the negative 3, m to the 4th, because that was a minus 2. And I move my 3 to the bottom, so I have m to the 4th over 3 cubed, which we could write if we wanted to as m to the 4th over 27, because 3 cubed is 27.